The next technique, integration by parts, it's sort of like the product rule for differentiation, but in reverse. It's going backwards. Now, the way we do it, or when we use it I should say, so when we use it, you'll have two functions multiplied together, so a bit like the product rule, but one's not the derivative of the other, so you can't do a simple substitution, let one equal u and then the other becomes du, and so that sort of situation. This is how I remember the formula. The integral of u to v is uv minus the integral of v to u. Now, if you look at it closely, as I say, it is actually the product rule. If I was to move the integral of v to u to the other side, I'd have the integral of write down the first, diff the second, plus write down the second, diff the first. So that's where it comes from, basically. So each piece, how do I work out which bit's going to be which? So the question is obviously the u to v. So I've got to make one of those functions u, I've got to make one of those functions to v. How do I pick? Well, u, the way I choose it is so that when I differentiate it, it makes it an easier function. Something easier to handle. Now, dv, so that's my first one. Sometimes it doesn't matter. You look at both of them and you go, oh, it doesn't really make either easier. So then the other thing I look for is dv, something that can be integrated. So I'm going to have to integrate dv. So x times the sine of x. I've got two things multiplied together. One's not the derivative of the other, so I can't do a substitution. So what I said was I want to choose u, something that when I differentiate it, it will be simpler. So I have the choice of x, I have the choice of sine x. Well, logically I'm going to pick x, because if you differentiate sine x, you get cos x. It's really the same thing. You still got a trig function there. Whereas when you differentiate x, you get 1. And that's going to be simpler to deal with. You can check the other one as well, just to make sure. dv has to be something. So the other one should then be something I can integrate. Well, sine x, yes, I can integrate that, so it should be fine. So over the side, there's u equals x, so therefore du will be dx. dv is sine x, so integrate sine, I get minus cos. So remember the formula was uv minus the integral v du. So u times v will be x times minus cos x, and then the integral minus v du, well, minus in this case, so I end up with plus the integral of cos, and integrating cos is a relatively easy function to go and integrate. Integrate cos and we get sine. I've just moved it to the front, so I've got a positive at the front. That doesn't really matter, I suppose. Integral of log x. You might say, well, hang on, there's only one function there. You might be looking at it thinking, hang on, I don't have two functions multiplied together, but I do. It's just that one of the functions is the number 1. So I've got 1 times log x. Differentiate it so it becomes simpler, and you might think, oh, well, yes, I'll choose 1. Because when you differentiate 1, you get 0 was correct. But remember the other criteria was, what I'm left with then should be something I can integrate. If I apply the other criteria, I'd say, well, dv will be log x, and so I'll have to integrate log x. Well, that was the question anyway. So this one, I really don't have a choice. U is going to be log x, du will be dx on x, so dv is dx, v is x. Okay, so in this case, uv, there's the x log x, minus v du. And writing it in this notation, v du becomes really easy, because the x times the dx on x leaves me with dx. And integral of dx is x. Let's do a definite one. Integral from 0 to 1 of xe to the minus 7x. So u is going to be something that will make it simpler. So again, logically I'm going to pick the x, because you differentiate e to the minus 7x, you're going to get minus 7e to the minus 7x, essentially the same function. So u is x, du is dx, dv is e to the minus 7x dx, so v minus 1/7. Okay, Now remember, this is a definite integral, so when I write the uv down in this case, I have my limits that I still got to substitute in. We've also got to do the integral of e to the minus 7x. Up to you whether you want to substitute in before you do this integration or after. It doesn't really matter because the limits are 0 to 1 on both. What did I do? I waited. So integrate the second bit, I get minus 1 on 49 e to the minus 7x. Substitute in, and we have our answer. Oh, this is a fun one. Integral of e to the x cos x. Because think of the process. You got two functions. You got e to the x and you got cos x. So if I choose u to be e to the x, when I differentiate it, it becomes simpler. E to the x becomes e to the x. Oh, that's not simpler. So if I choose cos x, it makes it simpler. Differentiate cos, you get minus sine. That's not simpler. Oh, maybe I'll look for the dv. Got to be something I can integrate. Integrate e to the x, you get e to the x, so I can do that. So it doesn't really matter which one I pick. So I picked e to the x. Du becomes e to the x, dv is cos x, and v is sine x. Do you know why I chose it that way? Anyone guess?
Oh, they're all positive.
Yeah! To be honest, that is the only reason I did it that way. Because if I'd chosen u to be sine x, when I differentiated it, I would have got minus cos x. Doesn't really matter. uv minus the integral of v to u. So I've got e to the x sine x minus the integral of e to the x sine x, which is pretty much the same sort of question. So we do it again. However, we have to make sure that the way I chose the first time is the way I choose the second time, or I'm going to end up in a circular argument. I'll end up with 0 equals 0 or something like that. So u is e to the x, du is e to the x dx, dv is sine x, so we get minus, so much of her avoiding the negative. uv minus v to u, but now, look, I've ended up with integral of e to the x cos x again. That's where I look at it and think of it like an equation. So I'm saying the first bit equals the third line. I'll move the integral of e to the x cos x to the other side, and I've got two lots of the integral of e to the x cos x. So divide by 2, should really chuck in a plus a constant there because we know we need our plus constants. They're very important. Alright, so that is a technique known as integration by parts.